this video, we are going to explore the two examples on the Fourier series. First one is to represent x minus x square from minus pi to pi in terms of Fourier series. And second is when we have the exponential function and the interval in this case we are considering as 0 to 2 pi. Let's begin with the first example. Find the Fourier series expansion of this function from minus pi to pi, and also show that pi by 4 is equal to this expansion from the Fourier series. Firstly, we will find the length of the interval in this case. So what is the value of a in this case? Minus pi. Value of b is pi. b minus a is, that is 2 pi. Now Fourier series is equal to a naught by 2 plus summation n from 1 to infinity a n cos of 2n pi x divided by length of the interval, that is 2 pi, plus summation n from 1 to infinity bn sine of 2n pi x divided by length of the interval, that is 2 pi. Simplified form of this one is a naught by 2 plus summation n from 1 to infinity an cos of 2 is get cancelled with 2 pi with pi, so we have n into x plus summation 1 to infinity bn sine of n into x. Now we need to calculate a naught, an and bn Fourier coefficients. Starting with a naught is calculated as 2 upon length of the interval, that is 2 pi, integration from a to b. In this case a is minus pi and b is pi of the function with respect to x. This is equal to 1 upon pi integration of the function pi plus x from minus pi to pi. This is equal to 1 upon pi. Integration of pi is pi x plus integration of x, that is x square by 2. Limits are minus pi to pi, which is further is equal to 1 upon pi. Substitute upper limit, that is pi. So we have pi square plus pi square by 2 minus lower limit. When you substitute here as a minus pi, what we have, that is minus pi square plus minus pi square is, that is a positive pi square divided by 2. Simplify this. This is equal to 1 upon pi square plus pi square by 2 minus minus is plus pi square, negative positive is negative pi square by 2. This pi square by 2 is cancelled with this one. Finally we have 2 pi square by pi, that is equal to 2 pi, and this is the value of a naught in this case. Now calculate the value of an. So an is calculated as 2 upon length of the interval 2 pi from minus pi to pi. Function in this case is pi plus x cos of n into x dx. Basically it is a cos of 2n pi x by length of the interval 2 pi. So we are getting in this case as n into x. In order to calculate this integration, we need to observe the function. Both are the function of x. So we need to apply the isolate. This is the algebraic function and this is the trigonometric function. It means this is the first function and this is the second function. According to the isolate, First function is as it is. Integration of second function, that is sine of nx divided by coefficient of x, that is n, minus derivative of this term is 1, integration of this term, that is minus cos of nx divided by n, and already 1 n is here, so we can write this as n square. Derivative of 1 is 0, so there is no need to take the next term. Limit from minus pi to pi. Next step, observe sine and cos function at both the limit. Sine of nx at upper limit when x is equal to pi, that is sine n pi. Sine n pi is 0. At lower limit minus pi. Sine of minus n pi, that is also 0 because minus of sine n pi, and that is also 0. Whereas cos nx at upper limit, that is x is equal to pi, cos of n pi, this is minus 1 raised to power n, and at lower limit x is equal to minus pi, cos of minus n pi, this can be written as cos of n pi, and its value is again minus 1 raised to power n. Next step, we can directly write this as equal to 0. Now the simplified form in this case, we have 1 upon pi, negative negative is a positive, cos of nx divided by n square. Lower limit is minus pi, upper limit is pi. Substitute these values over here. We have 1 upon pi cos of n pi minus cos of minus n pi divided by n square. This is equal to 1 upon n square into pi. This value is minus 1 raised to power n, minus this is also is equal to minus 1 raised to power n, and finally we are getting in this case as a 0. So the value of an in this case is 0, where n starts from 1, because in the previous case we have already evaluated that a naught is equal to 2 pi. Next is calculate bn. Bn is calculated as 2 upon length of the interval, that is 2 pi, integration from minus pi to pi, function that is pi plus x into sine of 2n pi x by length of interval, and we have n into x, integrate with respect to x. So again we have the function in terms of x, and there is a two function. We are going to use the isolate. So this is the first function as it is algebraic, and this is the trigonometric function. So hence it is the second function. In this case, we have 1 upon pi. First function is as it is. Integration of sine nx is minus cos of n into x divided by n minus derivative of first term, that is 1, integration of this term, that is minus sine of n into x divided by n, and already 1 n is here, so we have n square. Derivative of 1 is 0, so there is no need to calculate the next term, and the limits are from minus pi to pi. So observe cos nx and sin nx for both the limits. So sin nx at upper limit, it is getting 0, and at lower limit again it is getting 0. Whereas cos nx at upper limit, it is getting minus 1 raised to power n, and for lower limit again minus 1 raised to power n. Since both the values are same, we can take this value over here And in the next step, we can write this quantity as a 0 because it is getting 0 for both the limits. So finally we have 1 upon pi plus x. In place of cos nx, we can write minus 1 raised to power n divided by n, and this negative sign we have taken outside. Limits are minus pi to pi. This is equal to minus 1 upon pi. Even we can take this quantity outside because it is in a multiplication and that is also not depending upon x. So we can write minus 1 raised to power n upon n outside, and remaining terms are pi plus x from the limit minus pi to pi. This is further is equal to minus 1 raised to power n upon n into pi, upper limit, that is 2 pi over here, minus, when you put the lower limit we are getting 0. This is equal to minus 1 raised to power n into pi multiplied by 2 pi. So finally expression in this case is 2 into minus 1 raised to power n plus 1 divided by n. Now the final Fourier series we have, the value of a naught in this case is 2 pi divided by 2 summation n from 1 to infinity, a n is 0. So this term is multiplied by cos nx plus summation n from 1 to infinity, the value of bn is this. So 2 upon n minus 1 raised to power n plus 1 sine of nx. Now there was a second question. We need to find that pi by 4 is equal to this expression, and from this expression you can observe that we have term as 1, 1 by 3, 1 by 5, 1 by 7, no sine, no cos, even there is a no square term. So basically we just need 1 by n form in a summation so that we can vary n and we are getting this form, as well as we need the alternative sign. So let's observe that for what value of x we are getting this expression from the Fourier series. From here we are having pi plus, we can take 2 outside, summation n from 1 to infinity minus 1 raised to power n plus 1 upon n sine of n into x, and on right hand side we have a function pi plus x. We can further simplify this. This pi is get cancelled with pi, and hence we have x is equal to 2 summation n from 1 to infinity minus 1 raised to power n plus 1 by n sine of n into x. This is also written as x by 2 is equal to summation n from 1 to infinity minus 1 raised to power n plus 1 upon n sine of nx. As per the requirement, we need pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, so on, from this series. So even you can observe that from the left hand side we are getting the value of x directly. So if we put x is equal to pi by 2, we just need to check from the right hand side whether we are having this series or not. Then from here we have pi by 4 is equal to summation n from 1 to infinity minus 1 raised to power n plus 1 by n sine of n pi by 2. This is equal to pi by 4 is equal to, expand the series, put n is equal to 1. We have minus 1 raised to power 1 plus 1 is 2 divided by 1 sine of 1 pi by 2, that is simply pi by 2, plus, put n is equal to 2. We have minus 1 raised to power 2 plus 1 is 3 divided by 2 sine of 2 pi by 2, that is pi, plus, put n is equal to 3, minus 1 raised to power 3 plus 1 4 by 3 sine of 3 pi by 2, plus, next term is minus 1 raised to power 5 by 4 sine, when we put n is equal to 4 we have 2 pi, plus minus 1 raised to power 6 by 5 sine of 5 pi by 2, and so on. Sine pi by 2 is 1, sine pi is 0, sine 3 pi by 2 is minus 1, sine 2 pi is 0, sine 5 pi by 2 is positive 1. Substitute these values over here. So final expression in this case we have pi by 4 is equal to minus 1 square is positive 1, and here we have positive 1, final is 1. This quantity is 0. Next is minus 1 raised to power 4 is positive divided by 3 multiplied by negative of 1. So this is equal to minus 1 by 3. Next quantity is 0. In the next case, minus 1 raised to power 6 positive by 5. But here we have positive and here we have positive 1. So this is equal to plus 1 by 5. Its next term is 0, but its next term we have minus 1 by 7 and so on. And here we have final required series. We can also analyze the Fourier series approximation from this graph. From here, you can observe that this green line indicates the original function. The domain we have taken from minus pi to pi, and this orange line represents the Fourier series approximation. Till now, we have taken the number of terms from the Fourier series by n is equal to 1. With the change of n, you can observe that how this Fourier series approximate the periodic function. Next question is, obtain the Fourier series for e raised to power minus x in the interval of this one. Starting with calculating the values of a and b. So a is in this case is 0, b in this case is 2 pi. Length of the interval b minus a is 2 pi. Fourier series of this function is calculated as a naught by 2 plus summation n from 1 to infinity an cos of 2n pi x by length of the interval, that is 2 pi, plus summation n from 1 to infinity bn sine of 2n pi x divided by length of the interval 2 pi. The simplified form of this one is equal to a naught by 2 plus summation n from 1 to infinity an cos of n into x plus summation n from 1 to infinity bn sine of n into x, where a naught is calculated as 2 upon length of the interval 2 pi, integration from a to b, that is 0 to 2 pi, of the function e raised to power minus x with respect to x. This is equal to 1 upon pi integration of e raised to power minus x is e raised to power minus x divided by the coefficient of x, that is minus 1, limits are 0 to 2 pi. This is equal to minus 1 upon pi e raised to power minus 2 pi minus e raised to power 0. E raised to power 0 is 1. So finally we have 1 upon pi e raised to power minus 2 pi minus 1. This is the value of a naught in this case. Now we need to calculate an. An is equal to 2 upon length of the interval, that is 2 pi, integration from 0 to 2 pi of e raised to power minus x into cos of nx. Same function over here. So in this case, we cannot apply the IDEC because neither e raised to power x gets 0 after some derivative nor cos nx is getting 0 after derivating. Thus, we need to use some another approach. So, we have already covered this integral formula in the first video, that is e raised to power ax cos of bx. This integration is equal to e raised to power ax divided by a square plus b square into a cos of bx plus b sine of bx. Use this formula in order to write the integration of this one. We have 1 upon pi e raised to power minus x upon minus 1 square is 1 plus coefficient of x in this case is n, so we need to take its square, into minus cos of nx plus n times of sine into nx. Limits are 0 to 2 pi. Repeat the same procedure. Observe the behavior of cos nx on upper limit as well as the lower limit. For upper limit, we have cos of 2n pi. This is equal to minus 1 raised to power 2n, and that is equal to 1. X is equal to 0. We have cos of 0. This is equal to 1. Now why it is getting a 1? Because we are taking an even number. Minus 1 raised to power even number is always 1. So for the upper limit as well as the lower limit, this quantity is 1. Whereas sin nx, for the upper limit, x is equal to 2 pi. We have sine of 2n pi, that is 0. And for lower limit, x is equal to 0. Sine 0 is 0. It means in the next step, this term is getting 0. So we can directly write this is equal to 0 over here. And in place of cos nx, we can substitute 1. So this implies 1 upon pi e raised to power minus x upon 1 plus n square into minus 1. This is 0. Limits are 0 to 2 pi. This is further is equal to minus 1 upon 1 plus n square into pi, because n is not depending upon x and we have taken negative sign outside. E raised to power minus x, lower limit is 0, upper limit is 2 pi. Now substitute the limit. We have e raised to power minus 2 pi minus e raised to power 0 is 1. And this is the value of an in this case. Now calculate bn. So bn is calculated as 2 upon length of the interval, that is 2 pi, integration from 0 to 2 pi, function is e raised to power minus x, sine of n into x, and integration with respect to x. Again we are going to use the formula over here. We know that e raised to power ax into sine bx, integration with respect to x, this is equal to e raised to power ax upon a square plus b square, where a and b are the coefficients of x in both the terms, into a sine of bx minus b cos of bx. Use this formula in order to find the integral. This is equal to 1 upon pi e raised to power minus x as it is, divided by minus 1 square 1 plus n square multiplied by minus sine of nx minus n times of cos of nx. Lower limit is 0, upper limit is 2 pi. Now we have already observed that sine at upper limit, that is 2 in pi, is 0, as well as for the lower limit it is also 0. Whereas cos of 2 in pi is equal to 1 and cos of 0 is also 1. So we can use these values over here in order to write the next step. So we can directly write this as equal to 0 and this value is equal to 1. Finally, we have 1 upon pi e raised to power minus x divided by 1 plus n square, and over here we have minus n. Limits are 0 to 2 pi. This is equal to minus n outside divided by 1 plus n square into pi e raised to power minus x, and x limits are 0 to 2 pi. This is further is equal to minus n upon 1 plus n square into pi. Upper limit is e raised to power minus 2 pi and the lower limit is 0. So minus lower limit 1. And this is the value of Bn in this case. So the final Fourier series in this case is a0 by 2, that is minus 1 upon pi into e raised to power minus 2 pi minus 1 divided by 2, that is it is get multiplied by 2, plus summation n from 1 to infinity an, that is equal to minus 1 upon 1 plus n square into pi multiplied by e raised to power minus 2 pi minus 1. It also further multiplied by cos of n into x plus summation n from 1 to infinity bn, that is minus n upon 1 plus n square into pi e raised to power minus 2 pi minus 1 into sine of nx. We can further simplify this term. If you observe that 1 by pi term is common in each one, so we can take 1 by pi outside. Even it has a negative sign, as well as this term contains the negative sign, so take it as outside. Also, e raised to power minus 2 pi minus 1 is the part of each term. Take this term outside. After that we have 1 upon 2 plus summation n from 1 to infinity minus 1 by pi we have already taken outside. Remaining term is 1 upon 1 plus n square into cos of nx plus summation n from 1 to infinity n upon 1 plus n square into sine of nx. This is the final Fourier series approximation of e raised to power minus x from 0 to 2 pi.